Calculus! This is AP Calculus Lesson 5-8, Piecewise Integration. Today is November 29th, 11/29. It is one day before Mr. Sindell's birthday. All right, so yesterday we did a bit of piecewise functions. Today we're doing it a little bit more formally. Let me go find my notes to go off of as well. That would help me out. All right, so I've given you this graph to the right. I need you to find the area underneath that graph. Do you remember how to do this? All right, how do you do it? Tell me, walk me through it.
First you have to make a rectangle?
Yeah, you draw the parameter things.
Okay, so line at 4, line at 1, okay. Goes from 0 to 4, so 0 and 4. What next?
And to make it a little bit easier, you at the end point of the curve, no, the other one. The other one. Middle. There you go. You could draw a line. You could draw a line
So
there.
divide it into like basic shapes.
Ah, basic shapes,
Find
okay.
the area.
What about this shape? Do you like calculating the area of trapezoids, or do you only like squares and triangles?
It's easier to do squares and triangles.
Or I guess rectangles and triangles. Yeah, I agree, it is. I mean, there is the formula for doing trapezoids, but most people would prefer to do it this way. Okay, I've divided up my shape. I'm finding all, by the way, usually you want to do a rough shading, say like, okay, this is the area that I'm going to do. You can do shading like that. Technically, we should be doing bars because that's really what we're doing, but bars might mess you up in terms of dividing up your area. So if you do choose to do diagonal shading, that's totally okay with me. All right, so there's the area that I'm looking for. What do I do next?
Well, we first know about the rectangle.
This rectangle here?
Well, both rectangles maybe.
Okay, both rectangles. Tell me the area of this one then.
So that one would be 2.
2 and
The other would be 6.
6. We all agree?
Yeah.
All right. What about this triangle, Ben?
So, do the area of the square, 2 times 2, 1.
Yep.
And divide by 2, so it's 2.
Perfect. There it is. Yeah. And the reason that I always say find the area of the square first is because there are just students in every classroom. I know there's only 3 of us, and that means it's going to be one of you that will make that mistake on the pretest or the test where they just forget to divide by 2. Or they forget the area formula for a triangle. If it's the same procedure over and over where you always find base times height and then divide by 2 if it's triangle, then you'll make mistakes less. All right, but the whole point of this is review and then now to get to the equation. So what is the equation of this line right here? Stopping right here. So stop from 0 to 2. What is the equation of this line? As if it was I know it's a line segment right now, but if this was a line that went on forever and ever that way, forever and ever this way, what would be the equation of that line?
Would it just be f of x?
X plus 1.
X plus 1.
It's x plus 1, yeah. Because the y-intercept is 1, the slope is 1. You just do slope-intercept form, so it's just x plus 1. And then we say, okay, well, where is that for? You do a little semicolon, and you say this is for what x values, where x is where?
0 to 2.
Yeah, from 0 to 2. So technically, I guess if this went, yes, you are right, from 0 to 2. I guess we can make this a little bit formal. From 0 is less than x is less than 2, like that.
Maybe it's less than or equal to.
And it could be less than or equal to. I mean, one of these, this one's going to be an equal to, or this one is going to, we don't know. We can just make that one an equal to. Do you want to choose to do it now or later? Because one of these needs to be an equal to, that way it connects up. So it actually is equal to it at that point. I'll show you in a sec, okay. Give me the equation of this line segment from 2 to 4 as if it went on forever and ever.
It would just be 3.
Just 3. It's the constant function y equals 3. And that's for which x values?
2 is less than or equal to x.
Which is less than or equal to 4. Or maybe not equal to though.
Could only be 1 equal to?
In terms of the suspect point, so let me underline these guys. This right here and this right here, that is our suspect point. So this 2 right here, that is our suspect point.
So if both of them were equal, it wouldn't make sense, right?
Usually, yeah, usually you only want one or the other. And again, that's being really pedantic, Arrow's word. It doesn't really matter. They're not going to take off points, and I won't even take off points if you do a free response question like that. But that's generally how those are formatted. Okay, so easy peasy. We know how to find area from a graph. We know how to get from a graph to an equation. Well, now use your equation and see if you can just only use the equation to find the integral. Calculate the integral. Evaluate the integral.
So would you just plug in the numbers?
Kind of. Yeah, maybe I should set this up a little bit more. So this guy is going to be equal to, there's going to be two parts of this. There's going to be an integral here and an integral here. There's two integrals. So the first integral is from where to where?
From 0 to 4?
Some 0 to, careful, because 0 to 4, I agree, is the original integral. But this part right here, we're only dealing with x plus 1. X plus 1 is from where to where?
Oh, 0 to 2.
0 to 2, exactly. And our equation was
X plus 1.
x plus 1. That's going to be multiplied by dx, because I always do parentheses because this is the height and this is the width. Height times width is area. Perfect. Okay, and then that's going to be added to another integral, this time starting where?
2 to 4.
Yeah, 2 to 4 of what?
3.
3
Dx.
dx. There it is. That's how you set up that problem. And now let's go ahead and solve for this problem. Oh man, this hat is like ripping so bad. I wonder if I can wear it upside down. It's the new one too. It's a little bit too tight that way. Yeah, I need to like attach it to a baseball cap or something. All right, so calculate the integral over here. What is it going to be?
It would be 0. I mean 2 plus 1. So that.
Next to 1.
Oh, I was thinking it would
Oh.
just be 2.
Okay.
Okay. This is not
So
working.
yeah, it would be 1 minus 3. What?
What is going How about we take the antiderivative first, and then
Oh, okay.
and then do
Sorry,
stuff
I was
later.
doing it. Sorry, my bad.
Antiderivative of x plus 1 is,
2x?
oh
No,
god,
no,
I've left
wait.
for too long. This is what happens.
X.
Well, it was x to the power of 1, so now it's x to the power of
2.
divided by,
2.
there it is, okay.
Oh.
Oh,
Perfect.
I was taking
Sort
the
of
derivative.
roughly close. Anyway.
Okay, take the antiderivative of 1.
0.
That's the derivative.
Oh.
Go backwards.
2
Oh.
or
What?
x squared plus x.
Yes.
X squared over 2.
X.
It's just x, yeah. Okay, evaluation bar between 0 and 2. And then we're going to add this to this guy. Antiderivative of 3 is
3x.
3x. Evaluation bar between where?
4 and
Yeah, you want to say 2 to 4.
2.
You always start with the lower one. Yeah, I know what you meant, but we're just practicing on saying it correctly. All right, so when I do that, this thing is going to be equal to, maybe I should do it below it because it's a little bit easier to see. So if I go below here, if I plug in the 2, do you guys like me showing all my work, or can I skip to what 2 squared divided by 2 is? I'm going to skip work.
Yeah.
2 squared divided by 2 is?
2.
No, it is 2. It is 2. I don't know what I'm saying.
2 plus 2.
2 plus 2, yep.
So equal 4.
And then I'm going to subtract what?
Minus 0.
0 plus 0, yep. Okay, that was this piece, and now let's do the other piece of the piecewise function. 3x evaluation bar between 2 and 4. That's going to be 3 times what? Or maybe we can just skip right to it. 3 times 4 is 12 minus 6. There it is. All right, and then so this whole thing was this piece. This piece was being added to this piece. So I'm adding 4 plus 6. 4 plus 6 is?
10.
There it is.
Sorry, I was mid-yawn.
All right. So yeah, the procedure. We've already done the procedure. Let's write it down explicitly so we know what we're doing. The first step is to get it in. If you have 2 pieces, that means you have 2 integrals. 2 pieces means 2 integrals. If you have 3 pieces, you have how many integrals?
3.
Yeah, it's pretty straightforward from there. And that's the only key step there for step 1. Antiderivative next. And then this was kind of a key point too. So where did we have our antiderivative? When we were taking our antiderivative, in fact, I guess this a and b can technically be put under 1, 2. But what were the bounds when we were taking the antiderivative? Where was the start and end of the first piece? So we went from the start to this thing. What do we call him?
Sorry.
Suspect point.
Yeah, so we went from start to the suspect point. And then we went from where to where?
The suspect point to the end.
Yep, suspect point to the end. And this is reaching all the way far back to, was it Unit 1 or was it Unit 2 where we talked about suspect points? I think it was Unit 1. Yeah, the suspect point is the point that we don't know whether or not it's equal, so you plug it into each of these to see if it's continuous, and then in like Unit 3 or something, another unit, we had to take the derivative and plug it in, and it's still called the suspect point. So it's just reviewing that vocabulary. That's still our suspect point. All right, so we have one example and we're done with the notes, and then we can begin on the homework. I gave you the piecewise formula. I told you where the suspect point is at 2. Go ahead and take the integral of this guy. You guys think you can do it on your own?
See?
Try it.
All right, let's go ahead and do it on our own. I'll silently do it up on the board, and you can check your work. Uh-oh, got a weird face from Arrow.